Welcome back, guys. We're going to practice finding Taylor and something else called Maclaurin polynomials. By the way, Maclaurin polynomials are just like a special case of Taylor polynomials. So we're just going to work out some examples here in 9.4b. All right, so Taylor polynomials can be centered anywhere. So this is where it's centered at x equals some c value. Maclaurin polynomials have to be centered at 0. So technically last time we were looking at a Maclaurin polynomial. Taylor polynomials cover Maclaurin. Like a Maclaurin polynomial is a special type of a Taylor polynomial, so sometimes I'll just call them Taylor polynomials anyway. All right, but with the Taylor polynomial, we've got this first term, then we've got the second term times x minus c, and that's how we center it at c, is we have x minus c instead of just x. And then we have our second coefficient, x minus c squared, our third coefficient, x minus c to the third, our fourth coefficient, x minus c to the fourth, our nth coefficient, x minus c to the n, and this would be a degree n polynomial. All right, and we could just keep going forever if we wanted to, and that would work too. All right, for the Maclaurin ones, well, we don't need this minus c because it's minus 0. Right, so we just get rid of that minus c, and that's technically a Maclaurin polynomial. All right, and the way we get all these a sub n's is we take derivatives and plug in where we're centered. We plug in, so if we're centered at c, we take the derivative and we plug in c. All right, and then we always end up dividing by these n factorials because of the bringing down the n and stuff. So the general term, the general, I guess, formula for any term is the nth derivative at c, where it's centered, divided by n factorial, and that gives us the coefficient of the x minus c to the n, the nth degree term, which, if we put this together, gives us that this is what our polynomial looks like. All right, so our polynomial of degree n is the function value at c, the derivative at c times x minus c, the second derivative at c over 2 factorial. Technically, this was over 1 factorial, and this was over 0 factorial, but we generally just don't write those. And then x minus c squared, and then it'd be f triple prime of c over 3 factorial times x minus c to the third, and so on, all the way to fn. So the nth derivative at c over n factorial over x minus c to the n, and that is the nth degree Taylor polynomial. We could keep going if we wanted to. This is Taylor technically because it's centered at c. If we did it all at 0, we could call it a Taylor if we want, but the more proper name would be a Maclaurin polynomial for f. All right, so find the Taylor polynomial P sub 4 for f of x equals ln of x centered at 1. So the first thing we need to do is find derivatives. For f of x equals ln of x, because we need all those coefficients. All right, so our regular f of x is just ln of x. So if we plug in 1, f of 1 would be ln of 1, which is 0. That's not really giving us any help there. All right, so now we take our derivative, our first derivative. Derivative of ln of x is 1 over x. If we plug in 1 there, f prime of 1 is 1 over 1. It's 1. Hey, that's going to give us a term. If we look at now the second derivative, well, we could say this is x to the negative 1. So it'd be negative 1 x to the negative 2. And then f double prime of 1 would just end up being negative 1. And if we look at our third derivative, bring down the negative 2, we get 2x to the negative 3. And then f triple prime of 1 would just be the 2. And we need at least 4 derivatives. 4 is where we start writing it with the number 4 in there. Bring down the negative 3, we're going to get negative 6x to the negative 4. And if we plug in 1 to that, we're going to get just that negative 6. All right, so there's our coefficients, or there's our a sub n's, I guess. All right, now don't forget to put them all over n factorial. So then our 4th degree Taylor polynomial centered at 1 for x is, well, it starts off with this guy, 0 times x minus 1 to the 0, technically over 0 factorial, plus 1 times x minus 1, where it's centered, over 1 factorial, plus negative 1 x minus 1 squared over 2 factorial plus, now we're at this guy here, 2 x minus 1, let's see, to the third over 3 factorial plus negative 6 x minus 1 to the fourth over 4 factorial. So that's technically correct right there, but we could simplify this. All right, so this first term, it's times 0, it's going to go away. This second term, this 1 and this 1 factorial, we don't need them. It's really just x minus 1. Our third term, 2 factorial, is just 2, and we've got a minus here, so we could say minus x minus 1 squared over 2. And then we've got plus, let's see, the 2 and the 3 are going to, 3 factorial are going to cancel. This is 3 times 2 times 1. So those are going to go away. So it's just 3 on the bottom. So we get x minus 1 to the third over 3. Then we've got, looks like a minus. 4 factorial is 4 times 3 times 2 times 1. Those are going to cancel with the 6. We still have the minus sign, which I already took care of. We still have a 4 on the bottom. And we have x minus 1 to the fourth. All right, so if you want, you can put this over 1, but it looks like there's a pattern. It's to the first over 1, to the second over 2, to the third over 3, to the fourth over 4, and we're alternating signs, positive, negative, positive, negative. So p sub 4 of x is equal to that. And it often will follow some sort of pattern, but there's our Taylor polynomial of degree 4 for ln of x at 1, centered at 1. All right, Maclaurin polynomial. All right, Maclaurin, remember, means the center is 0. P sub 4 and P sub 6 for f of x equals cosine of x. Use P sub 6 to approximate the value of cosine of 0.1. All right, so we want some derivatives then. We need at least 6 of them. So f of x is cosine of x. F prime of x, derivative of cosine is negative sine. F double prime, derivative of negative sine is going to be negative cosine. F triple prime, derivative of negative cosine is back to positive sine. Fourth derivative, derivative of sine is just cosine. Fifth derivative, derivative of cosine is back to negative sine. And now we're kind of following this pattern all over again. Sixth derivative, negative sine is negative cosine. All right, and if we plug in 0 to each of these, cosine of 0 is 1. F prime of 0, sine of 0 is 0. Cosine of 0 is 1. We've got a negative here, so negative 1. And it looks like all the signs, all the terms that are signs are going to be 0, and all the cosines are just going to be 1 or negative 1. All right, so this is a sine, so it's 0. This is a cosine. And it's got a negative, so negative 1, and so on. All right, so now we can find our polynomial. So p sub 4 is, well, our original value, plus 0 times x minus 0, so just x to the first over 1 factorial, plus negative 1, x squared over 2 factorial, plus 0, x cubed over 3 factorial, plus, here's 4, 1, x to the fourth over 4 factorial. So there's our p sub 4. So the 0 terms are going to go away. So it looks like all the odd terms are gone, and we're left with just even terms. So p sub 4 of x, I should put an x in there, is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. All right, now we should start to recognize a pattern, like the signs are alternating, and it's just the even guys, x squared, x to the fourth, and on the bottom it's 2 factorial and 4 factorial, the same as the exponent. So if we wanted to, if we just recognize the pattern, p sub 6 should be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, and this was plus, so the next one should be minus x to the sixth over 6 factorial. And yeah, that's what we get. 0 for the x to the fifth term. There's a minus 1. So it'd be minus x to the 6 over 6 factorial. So there's p sub 6 right there. And we want to use that to approximate cosine of 0.1. So cosine of 0.1 is approximately equal to p sub 6 at 0.1, which is going to be 1 minus 0.1 squared over 2 factorial, which is just 2, plus 0.1 to the 4th over 4 factorial, which is 24, minus 0.1 to the 6th over 6 factorial, which is 720. All right, so these guys should be getting real small really quickly. So let's see, let's get our calculator out and see what that actually matches. So we got 1 minus 0.1 squared divided by 2 plus 0.1 raised to the 4th divided by 24 minus 0.1 raised to the 6th divided by 720. Oops, forgot my divided by. Insert division. There we go. That should work. 0.995. All right. All right, remember we always want 3 decimal places in this class. 995, and then it's 004. All right, so we are pretty close. So, all right, now what's cosine of 0.1 equal to? All right, so hopefully I'm in the right mode here. So cosine 0.1 equals, well, would you look at that? They match perfectly. All right, complete match all the way down. All right, because this is actually how your calculator goes about evaluating cosine. It uses these polynomials as well. All right, so there we go. There's our answer. And it looks like it's a pretty good approximation. In fact, it's exact as far as we go, however many decimal places your calculator goes. Cool. All right, I think we got one more here, and then that's, yeah, one more here. So sine of x expanded about pi over 6. So if we were at pi over 6, that means we must be doing a Taylor polynomial, and we want 3rd degree. Okay, so we don't need too many derivatives here. So f of x is sine of x. F prime of x, derivative of sine is cosine. F double prime, derivative of cosine is negative sine. And f triple prime, derivative of negative sine is going to be negative cosine. All right, so that's all the derivatives we need, and we're plugging in pi over 6. Well, we might as well just draw the triangle for pi over 6. Pi over 6 is 30 degrees. This is the short side, long side, square root of 3. So sine here, or f of pi over 6, is the sine, which is 1/2. F prime at pi over 6 is the cosine, which is root 3 over 2. F double prime is back to sine, but now it's negative. So we get negative 1/2. And f triple prime, we're back to cosine, but we're also negative. So we have negative root 3 over 2. So there's my coefficients. So now let's go ahead and make our polynomial. So our polynomial of degree 3 for x starts with this guy, 1/2, and it'd be x minus c to the 0 over 0 factorial, so we don't need to write that, plus square root of 3 over 2, x minus c, which is pi over 6, to the 1st over 1 factorial. So that's this guy, done, plus negative 1/2, x minus pi over 6 squared over 2 factorial, plus this guy, negative square root of 3 over 2, x minus c, which is pi over 6 to the 3rd over 3 factorial. All right, now we can kind of try and clean that up some if we want, or we can just leave it like that. Technically, that's correct. On the AP exam, that would be marked correct. All right, we can bring down the 2's here and bring down the 2 there, and that would work. We can do that if we want. We can go positive, positive, negative, negative, and put the signs out in front. But again, this is perfectly legit right here to write as an answer on the free response on an AP exam. All right, and that's it for now. The next section will start with another example for, I believe, a Taylor polynomial or Maclaurin. I don't remember which one. And we'll talk about the error in these